So this is going to be a video, a short video introduction to PLC Io, input-output modules. Input from sensors, output to actuators. And I'm going to use SIMATIC S7 here as an example. So it's about kind of connecting this is a photo detector of some sort, photo cell that we connect to a digital input module. Okay, for DI, digital inputs, so also maybe for digital outputs, it's something about syncing and sourcing. Who is applying the power? This from take from National Instruments. Sourcing digital input. The load supplies the power, and the digital input has to sync the power. Sourcing, you supply the power, and the load has to sync the power. And here is for an output, we have a load. Yeah, well, these are outputs. So let's say it depends upon where you put the load. Here's the load, and then you have to sync it. And here's the load down here, and you supply the power. Syncing and sourcing. Current sync, current source. Okay, that was for digital input, digital output, transistor, source, and sync. Then we have digital inputs, SIMATIC sourcing. They are special modules. And here is a picture of how you connect these. That was sourcing, yes, you supply the power here. And then you have syncing, pretty much the same, but they are separate modules, depends upon where the power is. And then we have what we need to connect here is, for instance, a photo detector, SIC, which has a common. That's where we supply the 24 volts, and then we get back either a signal when it's active or passive. Normal open, which means that when the condition what's detecting is normal, we don't have a signal. Normal closed means when what this detector should detect is normal, we get a close contact and a signal. No signal, signal. And then again, it's connected in here. So here's the supply. Connection diagram. And then we have something called IO link, which is a new one, which there is a special module in the PLC, which can connect to modules using IO link. And here is some introduction to IO link, but remember, IO link is a point-to-point connection and not a field bus. What can be, if we go back here to this module, you can use this module here too. The module does not have to be located in the central rack next to the CPU. It can be located in what we call remote I/O, where we have a communication module that communicate with the I/O modules and also with the CPU some other place, using maybe Profib bus and hopefully in the future OPC UA field exchange, a standard, not a proprietary protocol. That was IO link, and Siemens, they have a IO link module 2, so you can use IO link with SIMATIC. And then we look at analog inputs, and here is just one module, which is a multi-module for RTDs, I think. No, it's current, voltage current, RTDs, thermocouples, and it's a standard module. And here is what kind of modules or sensors they can be used used with. So you have the PT100 and all variants, you have thermocouples and a lot of types, you have voltage and a lot of types, you have current 2-wire, which is preferred if you use this module, and then you have got current 0 to 20, 4 to 20 milliamps in 4 wires. 2-wire means that the module is supplying the power to your instrument or transducer, and the 4-wire means that you need a separate power supply, but it can still deliver 4 to 20 milliamps. But then you need 2 more wires. The cost for wiring is going to be the double. So use a 2-wire if you can. Yeah, and positive terminal characteristic is not what is called for a resistor. Yeah, so that was quick about I/O. We looked at digital I/O, sourcing, digital output sourcing, a principle. We look at digital input modules. We look at a SIC photo detector and how, with a normal open, normal close contact and a common, how to connect that. And we looked at IO-Link a little, and just a brief picture of IO-Link master. The Siemens has can use IO-Link devices, and one analog input module. And that was what this video was about.